want to say one thing real quick though. Oh, here comes Marcel. Let me say one thing and then we'll jump into any questions anybody has. Anybody got questions? I just want to say something in general. I don't know if anybody needs to hear this necessarily, but no matter what it is you're doing, if you don't do it as well as you want to, that says nothing about you as a person. I don't know if anybody needs to hear that. Sometimes I feel like students, and me too, I do this, I've done this my whole life, and I'm finally kind of getting out of it. If I did something poorly, I took that as being an indictment against me as a person. And those two things are completely separate, right? Because, okay, just wanted to put that out there in the world. So what you got?
Can you go over the finding section?
Finding.
In terms of graphing function?
Okay, just to remind everybody, on the practice test, 6B and 7 won't be on the next test because that's in section 8.2. Section 8.1 is how far we made it. 8.1 is graphing sine and cosine. 8.2 is graphing everybody else. Yes? Yeah, hold on.
Can I ask about a different?
Do it again.
And since we're not even focused on
So you want, I'm sorry, you want to?
Can we just go through like the 8 instead of, since we're not even?
Number 8? Sure. Yeah. And real quickly, Keisha, you don't have to say can, I mean, you could throw any question you have, right? You with me?
Yeah.
Everything's open, right? Okay. So number 8. Number 8 and 9 are the two hardest problems, I think. I don't know, you guys could disagree. Number 8, you could do all of it right and think you're wrong because the answer is going to be a little gross, which should kind of make sense. There's a lot of weird shit happening here. All right. When you see something like number 8, you read through it. Can anyone notice a couple of things I gave you that aren't evil, but that you have to catch that I gave it to you a certain way? There are 2 things specifically that I gave you a certain way that aren't exactly what you need.
You put diameter.
I put diameter, good. So always look for that, because the homework does it a lot, and I will do it every now and again. So one of the first things I want to do is go, almost everything we use deals with radius. So if I give you the diameter, the very first thing you do is convert it into radius. And how do you always do that? Cut the diameter in. How do you get the radius from the diameter? You cut the diameter in half, of course, because the radius just starts in the center, and the diameter goes out in both directions. It goes twice as far as the radius. So what's the radius for number 8? 14. Okay, now somebody else. Does anyone else notice a second kind of evil thing? You're like, oh, the whole damn thing, Jeff. That's what I noticed.
There's time.
Good. What about the time?
Um,
Something about the time specifically. How fast are you going?
minutes.
No, it's true, exactly. Because how fast are you going?
It says
60 miles per hour. And what time did I give you? Okay, so 30 minutes is how many hours? Half an hour. There you go. So the 2 immediate things that this evil math teacher did, and I'm not evil at all because it's practice test, I don't care, is I gave you diameter, damn you, Jeff, and I gave you minutes when you need hours. Damn you, Jeff. Okay. Yes, ma'am.
wouldn't the minutes taken cut in half talking about speed in terms of diameter? No.
We already cut diameter now.
Okay.
That's one separate thing. And my speed is in it per hour, so I just changed time to the hours. So we had to get radius because radius is what's involved in our formulas that we use. And we had to get hours because I need internally everything to match. My speed is in per hour, I want my time in hours. All right. I'm asking you how many revolutions, yes? You with me? So let me ask you this real quick, side question. Because the whole thing with this problem is identifying what middle steps you need. So if I told you something is rotating, holy crap, 80, holy crap, inches per hour, yes? And I tell you that the circumference is 20 inches. How many revolutions per hour is that? If I rotate 80 inches every hour and the circumference is 20 inches, how many rotations per hour? How'd you get that? So if I could figure out how quickly it's rotating in this case it's going to be, was it centimeters? I can't remember this problem. If I could figure out how quickly it's rotating in inches, inches per hour, and I can figure out the circumference, I could very easily figure out how many rotations. Yes? Okay, let me stop for a minute. Can anyone, let's start with the easy part. Did everybody understand what I just did? I thought to myself, if only I knew this and this problem would be easy. All right, get those things from what I told you. So can anyone tell me the circumference of this wheel? How do you get the circumference of this wheel? What is the formula for the circumference of a circle?
ID or half pi r.
I love it. So pi d or 2 pi r. So in this case, the circumference, I could use the original diameter if I want to, or the radius, but it would both come out the same. So the circumference would be, we'll just use 2 pi r just because. 2 pi times 14, yes? So I'll leave this as 28 pi for right now. 28 pi what? Inches. Now you start to realize the third kind of evil thing. By the way, I tell you up front, number 8 is really not straightforward. If I did put like a problem fully like number 8 on the test, I would have a few steps. Part A, find this. Part B, find this. Okay. My circumference is in inches. What's my speed in? What's my speed in? What's the units on my speed? Miles, good. So miles per hour. Okay, so we have another layer of unit mismatch. So what I could do is I could either convert circumference into miles, or I could convert the speed into inches. And I would much rather convert the speed into inches. Do you guys understand why? No? Is it because I don't want to get really, really, really tiny numbers and then have to write all those decimals at number? Okay. So we are going 60 miles per hour. Can you convert that to inches per hour? Can you do it? Maybe you don't. Does anyone know how many inches are in a mile?
5,760.
Do it again.
5,760.
All right, 2 things. You're really close, but the wrong units. I don't know how many inches are in a mile. Are you kidding me? I don't have that number. Anybody know how many feet are in a mile? You're really close. 5,280. So there's, for every mile, there's 5,280 feet. And for every foot, there's how many inches? 12 inches. Okay, good. Let me say again what I just said earlier. If I gave you this problem on a test, there would be part A, part B, part C. for sure, because this is a lot of steps. I just put this down there to see who would play with this thing, who would notice what's required, who would notice the units aren't matching. Yes? That's one of the first things you want to look for. I am not. Did I ever tell you guys about does anyone ever play basketball? Anybody ever watch basketball, play basketball? You guys, anybody? You guys have ever heard of basketball? Okay, alright. Like my Celtics kicked ass like they should. But have I told you about this? If you want to play basketball, you want to play really well, they actually sell a basketball that is a little bigger. Same weight, but just a little bigger than a normal basketball. Are you guys with me? You guys with me? Okay. So if you practice with that thing, and you're getting it in the hoop pretty well, and then you go play a game with the same weight, smaller ball, hey. So I often use that analogy for my practice tests. Very often I'll make my practice test a little bit harder because you're able to access all your notes to do it and so forth, right? So I am not going to give you a problem like number 8 just out of the blue on the test. You with me? That is not what I'm communicating to you here. This is me saying, how far can you make it with this without me helping you with the steps? What can you see in this problem? Where do you hit a wall? First 3 things we did were because we noticed a mismatch. Minutes, but the other part is hours. Diameter, but I normally need radius, right? And then we noticed inches, but the thing is in miles. Okay, so that's what we're taking care of right now. If you multiply all that out, what do you get? Did I do that? Where's mine? Yeah, somewhere. I'm not going to do that in my head. Just to let you know. Okay, you go. 38.
3801,600.
3801,600.
Yeah.
Okay, and what would the units be? What units are left alive?
Per hour.
Inches per hour. Kick ass. So that's how much we are. We're traveling is that many inches per hour, and we know the circumference is 28 pi inches, and we know we're traveling for half an hour. So, real quick, right now, could you guys help me figure out? We are going 3,801,600 inches per hour. Can anyone figure out how far we go after half an hour? What would I do? If you let half an hour pass, how do you figure out how far you've gone? If 2 hours passed, how would you figure out how far you've gone? Multiply. Okay, half an hour passed. How do you figure out how far you're going? Does the idea change? Multiply by half. So cut that sucker in half. And you get... do I want to do this in my head? No. What is it? 1908. No. Did I lose a 0?
Yes.
8. Like that? Go, Jeff. It's almost like he knows this shit. So if I multiply by half an hour, I get the total number of inches I've gone. Yes? Now, what's the last thing I need to do? Just to remind you guys latched on to this idea really easily. In fact, if I rotate 80 inches and my circumference is 20 inches, how many rotations did I do? 4. All right, how far did we rotate? This far, yes? How many rotations is it? Well, what's one rotation?
360.
No, come on. We calculated it. For this tire, one rotation is how many inches?
23.
Good. So like I just said, if we rotate 80 inches and every rotation is 20 inches, we did 4 rotations. Here we rotated this many inches and every rotation is this many inches. How many rotations? How many rotations? Don't let the ugly numbers get in your way. We're humans. We invented those damn numbers. They do what we want, huh? No, stop. Okay. If I went 80 inches and my circumference is 20 inches, is everybody really cool with that's 4 rotations? Do you guys get that? One rotation would be 20 inches. So help me out. What would one rotation of this tire be? How far would I go if the tire rotated once?
20.
28
28 pi inches, yes? What if it rotated twice?
46.
56 pi inches, I'm with you, don't worry. How many inches did we go? This many, so how many rotations did we do?
Whatever that is divided by
That divided by that. Your brain doesn't like that because it can't do those numbers, but we have a stupid calculator, right? All we need is the brain to go, oh, this is what you type. But I think for us, and I don't blame you, you look at the numbers, you go, how does this guy expect me to do this shit? I don't. You just have to know what to plug in the calculator. And what do you do in this situation? You divide, the same way we did with the nice numbers. So one little trick I try to teach, like when I teach algebra, back in the day when that was legal to do in community college, I would tell them, replace the ugly numbers with nice ones, see what your brain does. And then do the same shit with the ugly numbers. That's exactly what I was trying to do earlier. So if you take 1,000,009 divided by 28 pi, you gotta be really careful when you plug it in your calculator. Did I bring a calculator? No. What am I, a math teacher? Yeah, that's right. Be really careful when you plug it in. Oh, thank you. Oh, sorry, Marie. One little thing. So you got to do.
as well.
No. Let me see. Can you guys see that? Okay. 19,008,00 divided by parentheses 28 pi. Right? So you should get that. Yay! For a minute I was like, that doesn't sound familiar. That's what past Jeff got. Okay. That might have been the worst problem to start with, because now everybody's got this. That is one of the hardest problems on this practice test, and it is harder than the actual problem I would give you on the test. Yes? Oh yeah. You probably also need a copy of the last quiz. Yes. Anybody else? Oh. Wait a minute. Okay. What do you need? Practice test, copy of the quiz. Oh shit. I just ran out of the quizzes. If you email me, I can send it to you. You need a copy of the practice. Oh yeah, okay. Is everybody else good? Oh. Oh. Yeah, the practice. If you want a copy of the quiz, you gotta email me this. I think I used them for scrap paper somewhere. Most of the copies. Everybody else good? Oh. You need a practice test, right? All right, is that everybody? Everybody's good? Okay. Okay. The important thing on problem 8 is, what did I first take care of? What did I first notice? And then how did I think about what to do? I always think that students are stuck in the mindset of, this kind of problem will look like this. This kind of problem will look like this. That is so wrong. It is so wrong. You've got to give yourself practice to think, if I only knew this, this would be easier. Okay, let me try to get that. It's not going to be cookie cutter problems. It just isn't. Especially once you get to calculus. Forget about it. I'm not saying calculus is going to be horribly difficult, but you do have to kind of let go of memorizing. When I see this, I always do this. No. You have to understand the concept so you know how to apply it. Anybody try out number 9? I don't blame you if you didn't. You did, Ricardo? How'd it go? Did you get an answer?
Yeah.
Okay, hold on to it. I'll open it up. Anything else you guys want to focus on? Yes.
6A.
All right, so. Help me out now. What is the amplitude? 3. What if I put a -3 here? What would the amplitude be? Good. What would -3 just tell you? It would go up to 3, down to -3. It would just take the whole thing and flip it. Whoop-de-doo. How do I get the phase shift? What do I have to do first? I can't currently see it. It's not left pi. That is not true. Because is that happening to x? Am I adding pi to x? Am I adding pi to x? No, I'm adding pi to 4x. I need to know what I'm doing to x, because that's what tells me how it's going to move along the x-axis.
Take out the foot.
Take out the 4. How do I do that?
Factor.
True. How do I do that?
Oh, it's going to be 1x plus pi divided by 4.
Good, because when I take something out, I divide it out. So now I can see my phase shift. And by the way, in case you've missed some classes, can somebody remind me? We call it a phase shift, but it's just a fancy name we use for trig functions. What is it really? It's just how much it, what's the phase shift? It's just how much it moves left or right. Beautiful. So it's just a horizontal shift, right? We just call it phase shift because, for example, one major thing we use trigonometry for is to represent electromagnetic waves, like electricity running through. And we talk about the phase of it. It's got to be an in phase, out of phase. Transformers, step it up, step it down. So, just to let you know why we use the word phase out of nowhere. So what is the phase shift here? Same thing as before, yeah. What's happening to x? Adding it, so I'm going to be left pi over 4. Kick ass. So I already know it's going to start where?
Left pi over 4.
So where's it going to start? Negative pi over 4, beautiful. Because it normally starts at 0. Cosine and sine, the way we decided to do it was we start them at 0. Now it's going to start at negative pi over 4. What is the new period? What is k?
4.
4. So what's the new period?
2.
The old period divided by?
New period.
Divided by 4. So what's the new period?
1/2.
Pi over 2. So, in the past, before this came along, it took cosine 2 pi to get through its complete cycle. Now it's going to take it just pi over 2 to get through its complete cycle. We've gone from radio waves to maybe electromagnetic spectrum. We've shortened the wavelength. It's all compressed now. So everything I need you to really, the reason I keep bringing up like electromagnetic waves and all this kind of shit, everything we're doing right now is immediately applicable to things in the real world, like electromagnetic waves. Okay. One thing I didn't write up there for some reason, and I will write it on the test, is what's the new step size?
8 is the new period divided by
Yeah.
4.
How far I've got to go, cut in fourths, because the steps, there's 4 steps always. What is pi over 2 divided by 4?
Pi over 8.
Cut something in half, cut those in fourths, I cut it in
8.
eighths. Okay. You might as well circle everything. Why not, Jeff? Okay. Now, if you want to, on the test I'm going to say, find the beginning and the end of the cycle if you want. Because like I said, if you do the homework and you get to a point, you might realize you don't need that. And I kept pointing out that the beginning and the end is nice because it verifies what we've already done, which kind of means I don't really need it. But it still feels good to do some math and go, oh yes, the same shit I got before, then come. So does anyone remember how to figure out where this new thing begins now?
You set it to before.
Yeah, normally cosine starts when the inside is 0. So now, if I do this, subtract pi, divide by 4, I get exactly what you guys are telling me. It's going to start now at negative pi over 4. So that jives with what we already knew. Where's it going to end?
Same thing, but
When will it end, Jeff? When does it normally end?
2 pi.
2 pi. So now it's going to end at positive pi over 4. And what does that make? Somebody with me? That's almost too nice to believe. So if I take the inside and I set it equal to 0, because 0 is where cosine starts normally. So if I make the inside 0, I now see what input makes cosine start. Where did cosine normally end? 2 pi. So if I set the inside equal to 2 pi, I see where this function ends. Can somebody remind me what the period for this one was?
Pi.
Pi over 2. And what does period tell you? What does the period of a trig function tell you? Yeah, how long it takes for the cycle to get done. And what did we just say? The cycle begins at negative pi over 4 and goes to pi over 4. How far apart are these two?
Pi over 8.
Pi over 4 minus negative pi over 4, right? If I want to figure out how far apart two numbers are, I subtract them. What's pi over 4 minus negative pi over 4? Pi over 4 plus pi over 4 is?
Pi over 8.
What's pi over 4 plus pi over 4? Let me write it down. Nope. I love you guys. So pi over 4 minus negative pi over 4 is pi over 4 plus pi over 4. Same denominums. Okay, so listen. Period tells me how long from where it begins to where it ends, yes? How long that cycle goes. We know it goes forever, but we're just focusing on that one little slice that we're going to graph. We just figured out it begins at pi over 4, negative pi over 4, and ends at pi over 4. That jives. That's pi over 2. Yes, it takes it pi over 2, and we just said earlier it's supposed to take it pi over 2. Do you see what I mean? The beginning and the ending, that step is actually unnecessary. But if I were you, and I'm just learning this shit, I'm going to do it just to kind of go, okay, everything's kind of working out.
Where does the minus pi come from?
Where's the, here?
Yeah.
I'm just solving for x.
Oh, okay.
Yeah, okay. Oh, I breathe.
Yeah.
Wait a minute. Sorry. You want that?
Oh, thank you.
Sure. All right. So now we have to graph this thing. Do you guys want to take a minute? We did all this work here together. Can you guys, if you want to, try to graph that? And then we'll do it together. So go ahead and try to graph that. If you don't want to do that, look at some other problems. Yes, sir?
Since we're not doing tangent or
Secant?
secant, is there something else we can replace that with?
Oh, I'm gonna probably, for example, to be really honest, the test is gonna be long enough the way it is, so it's actually kind of nice we stopped at 8-1. If you weren't here, I announced there's gonna be 2 parts to the test. Part 1 you can't use a calculator for. When you turn that into me, I'll give you part 2, and then you're allowed to take a calculator out, or I'll have my calculators you can borrow. Somebody with me? I will tell you when you should be about done with part 1 in case anybody's, because I want you to have enough time for part 2. You guys, part 1 is going to be the lightning round. It's going to be either you know sine of 30 degrees or you don't. Either you know how to analyze cosine of 5 pi over 6 or you don't. So it's like bam, 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 bam. Yes? And then you should be able to get part 2 and have enough time for part 2. Is everybody with me? So as it turns out, I think it's fine if I don't put one of those on there. Yeah, they'll be on the next test. The most I would do is like expand the section with reference angles. I'll give a few more problems there. Yeah. Yes. Say again.
Are you talking about A not being on?
No. Part B. See these that are circled?
Yeah.
We didn't get to 8.2. 8.2 talks about secant and cosecant, and also talks about tangent and cotangent. Yeah. So 6B and number 7 on the practice test, if you just got that today, you don't have to worry about it. It's going to be on the next test. Homework is due through what? 8-1. So if you're doing 8-2 homework, yay, but then you go back and focus on earlier stuff, yes.
So the test is chapter 7 up to 8.
7-1 through 8-1.
Okay.
Cool. Which sounds like not a lot, but it's plenty. How are we doing with this? I keep interrupting you, I'm sorry. So here's the fantastic thing. I begin at, I've lost it, there it is, negative pi over 4. Holy shit, look at that negative. What was my step size?
Pi over 8.
Yeah, pi over 8. So here's what I'm going to do. What would make it easier to keep adding pi over 8 if only this stupid thing was in terms of, is it really easy to add negative pi over 4 to pi over 8 like in your head? I want it to be. So can't I just make this negative 2 pi over 8? Isn't that the same thing? Now can I step by pi over 8? I really didn't draw this well. I'm going to do it again. I just realized. I forgot at first we start in the negative. Okay, so I'm going to start at negative 2 pi over 8. And now how big is each step? Pi over 8. So then I'm going to go to pi over 8. Then I'm going to go to 0. Then I'm going to go to pi over 8. And then I'm going to go to 2 pi over 8, which is pi over 4. Yes, so where, Jeff, where did I start? Negative pi over 4? Where did I end? Oh, yeah. No. Okay. I love you guys. Okay. Are you guys with me? It's kind of nice. I just got through the cycle just using step size, and I got the same ending as I predicted when I did that ending work. So there's a whole bunch of checks and balances in this if you do it this way. Where does cosine, oh, what's the amplitude?
3.
So 1, 2, 3. 1, 2, 3. I'm not really overly concerned with shifting the damn thing up and down. If this problem had a +2 at the end, we would do all the work we're about to do, and then I would just take what I get and I would move it up 2. You guys would, every point would just go up 2. What do you do? I almost don't care about that. Where does cosine start? At the max. Yes? Cosine starts at the max, goes to 0, min, 0, max. So I start here, so where do I start? Yeah, the output will be the max, because they didn't flip it, it's not negative. And then the next step, holy shit, Jeff, make that big. The next step is here, the next step is here, the next step is here, and the next step is there. I need you guys, when we do step size, and we do the steps, it makes this almost too easy to believe. All you have to do is remember, cosine starts big, goes small, comes back to big. That's all you have to remember, and you set up the steps. You set up where the hell the steps are. So, if it felt like that was a bit of work, and we haven't even graphed the damn thing, we were doing step size and beginning again, because that's all the work. The graph should be easy as shit after that. Now, the next thing to be careful about is I have had people in the past just kind of make it an absolute value, and I'm like, no. This is where we have to know what the thing looks like. It's simple, right? How do you fill this in? How do you connect them? Should it be? No, it should be. Make sure you put little arrows so I know you know it goes forever. So that's my cosine, been shifted back pi over 4. Right? I can see that one idea. I'm like, okay, it's got that idea at least. Good. If this would have been sine, what would have been different? If the only thing I changed was I made cosine sine, I would have started at 0, and then I would have went up, and then I would have went down. Yeah. Right? I would just put those points where I've identified. The step size does that for me. Okay. Maybe. Okay. And again, on the actual test, I'll ask you amplitude, phase shift, step size, new period, step size, right? So you don't have to remember all the things, I'll just ask you for them, and then you just have to put them together. Well, you have to calculate them, but then put them together. Okay. Now, we could do another example like this, or we could do a different problem, up to you. Number 9? All right. We're going to do it eventually. Can you guys, if I have a trig problem, if I'm in a section of trig, and I get a physical problem, what shape are you looking for, specifically?
Right triangle?
Right triangles, beautiful, we're looking for right triangles. We're going to learn later that we can actually use trig in things that aren't right triangles, but how do we do that? We find a right triangle and then we make a process. So fundamentally, I always have to find right triangles to be able to do anything with trig, because that's how they were defined, yes? How many right triangles do you guys see in that picture I made? No? 2. And by the way, I didn't do this to be tricky. You can just make this x. I think a previous version of this problem I had more going on. So believe it or not, this is scaled back. Where are my 2 right triangles? What's the easiest way to identify them? The right triangle that has a...
Angle?
They both have angles.
The
The right triangle that has a... I love it. The right triangle that has a 35-degree angle, and the right triangle that has a 32-degree. Okay, you with me? Do you guys see them now? There's 2 of them. One of them is inside the other one, but you know, they nest. They like each other. It's fine. So, look at the smaller right triangle. Yes? Don't worry about this guy at the beak here. Just look at the smaller right triangle. Do I care about the hypotenuse at all? Am I talking about the Hobbit setting up a zip line after they defeat, and they're like, I want to make a zip line, make a park out of this place? No, I don't care about that hypotenuse. Yes. What trig function relates the angle that I'm given in this guy, the thing I want to know, and the thing I kind of highlighted for you was important? Tangent. In fact, that's really the question, right? No, the question is the height, but this is in this right triangle, so I need it to help me get this. So what can I set up? Tangent of 35 degrees is?
X over H?
No, h over x.
Multiply both sides by X.
Sure, okay, hold on. So that's one relationship we got. We'll talk about what to do with it in a minute. Now look at the bigger right triangle. Can you write something similar? Be very careful that you include what's true about the right triangle.
I have to go to work. Can I get the answer?
Oh, right there. Okay. Look at the big right triangle. What can you set up? Tangent of 32 degrees equals
1,000
h over 1,000
feet.
plus x. Good, right? Because it's got to be the whole base. We can't do shit currently with this triangle, yes? Do you guys see that triangle? This triangle right here? That is freaky as shit. Anybody know what that kind of triangle is called? Scaling. Also obtuse. I love it because it's got an angle that's bigger than 90. Okay. All right. But scalene is the general name for a triangle that's not right. It's not isosceles. Poor little dude. Now, which variable are we trying to solve for?
H.
H. So here's the trick. This is the thing that students don't understand. Which variable do I not care about? Huh? No. What am I trying to solve for? H. I care so much about H because that's the answer. Yes? Which variable do I not give a shit about?
X.
Probably the only other variable there is. Yes? H I care about so much because that's the freaking question. Yes? X I don't give a shit about. You with me?
Wait, so just to make that clear, for the bigger triangle, we have to take both bases and add them together.
No. Well, yes, but be careful. What is the base of the, how long is the base of the big triangle?
Yeah, another 1,000 plus.
It's just that.
Oh.
That's it. I know, and you're right, we do have to add 1,000 to x. But to get the base of the bigger triangle, that's how long it is.
Right.
Okay.
But for the triangle inside the triangle, we just take the
Well, I mean, how long is this guy's base?
x.
X, yeah. Cool. Okay. So, there's a few different ways to do this. You were kind of on the right track, whoever said what they said, but do you guys understand? Let me see if I can do this. I don't care about x. So I need to solve for x. So then I can substitute that in. I care about h, yes? So what's happening right now? How many equations do we have? Two. How many variables do we have? We have too many damn equations, and the number of variables is too damn high. Right? Just like rent. So here's what I want to do. There's a few different ways to do this. I want to take number one, how do I solve for x?
Okay.
The first step is
Multiply both sides.
multiply by x. Can you guys see what the second step would be? Yes, so can you guys get here okay? Is that alright? Now, here's the trick. How do I solve this one for x? I do very much the same thing.
Yeah, you multiply both sides.
If I multiply by 1,000 plus x and divide by tangent 32, do you guys see that? You guys with me? Same thing we did here, actually. Yes? And then if I wanted to, I can subtract 1,000. But do you see how right now, what could I replace this x with? And then what's going to be the only variable in my equation now? What's the only variable in the equation? H. Now, listen. How many h's are in that equation? Is everybody cool? Anybody cool if I actually told you there's just one h in there?
Do you cross multiply?
No.
No.
What's the only time you can cross multiply? When I have one fraction equals one fraction. Then I can cross multiply. Is that what I have?
No, because
No, I have 1,000 plus a fraction. Oh, I can't cross multiply. Shit. So let me ask you this real quick. What if the equation was this? 1,000 plus 5x equals 6x. What would you do? How would you solve for x?
subtract 5x.
Oh, okay. Get all your x's together. Yes, because that's the variable I'm trying to solve for. Okay, what do you guys do here? What do you guys do here? Subtract h over tangent 35. Yes, good.
X equals 10 to,
Oh, sorry.
sorry, I thought you just messed up like the X value.
No, right here. Multiply by x, divide by tangent, so x equals h over tangent. So when I see an x, I can replace it with that. Because I just told myself, oh, that's what x is. So here's the secret of algebra. The secret of algebra is pretending like you know something when you actually have no idea. So if you ask me, what is this length, Jeff? Me being a math person, really strange person in this world, I would say, oh yeah, it's exactly h divided by tangent 35 degrees. But the reason we do that is because now I can just work with it. Instead of having blank space, I now have an expression I can put there. And I can do shit with that expression. So what do I want to get together? We just to remind you guys what we just did. What am I trying to solve for?
H.
And whenever you're trying to solve for a variable, at some point you want to get all of your variables
On the same
on one side. So what has to move?
H over 10.
Yes, so I get 1,000 equals h over tangent 32 degrees minus h over tangent 35 degrees. Is that cool?
So just tangent with the 3.
Hell no. So, a few things. Are those fractions?
Yeah.
Do they have the same denominator?
No.
No. So, first level is, I can't put those together. They're different denominators. We're not going to make like denominators. We're not. Second level is, if I had tangent of 18 degrees minus tangent of 8 degrees, is there any reason that should be tangent of 10 degrees? No! Is the square root of 18 minus the square root of 8, is that the square root of 10? No! Good! It is unusual for a function to allow you to subtract the insides. There are only certain functions that let you do that. Most of the time, we can't do that shit.
Wait, so if we go back to the fraction, the original problem we already, the h minus right? So you're telling me we have to multiply the right side by tangent of 32, then multiply the left side by tangent of 35?
Hell no.
To get the
Okay.
same number?
Okay. I have not used my space well. Let me write this last one again. How many h's are in that equation?
One.
1. There's 1 h. Right, and someday there's going to be a student that just gets up and leaves when I do that because they're like, I can't deal with this guy. There's 2 right there, man. But what can I do? Is there an h in both terms? Okay, what can I do?
Combine like two?
No, there's no like terms. We just said they don't have the like denominator. Yes? What can I do? What can I do here? Can I do anything here? Can I do anything here?
No.
I could factor out an x, yes? Okay. What can I do here? Factor out an h. Okay, don't overthink it. Don't overthink it. If I factor an h out, what's left?
Tangent of 30.
No. 1 over tangent 32 minus 1 over tangent 35. Yes? And now how do I solve for h?
Wait, you divide.
Nope. How do I solve for h? Divide. Good. Now listen. This is the exact same thing that happened to you with that tire problem earlier. Your brain does not like what it's seeing. Do you guys agree with me? If you think about it for a second, that's freaky as shit, Jeff. But real quick, on that problem I just gave you, look. If this equaled 11, how do you solve for x? Factor out an x, and then divide by 7 plus 8, yes? Because of course, how do I get something by itself? When it's multiplied, I just divide. So how do I get h by itself? Divide by? Don't worry, don't let your brain control shit. Divide by the thing I don't want. Die! All that is more writing than normal. All that is more writing than normal. I didn't do anything different than we would do on this problem. We did exactly the same steps here, just less writing normally, more writing now. Ooh, who cares? Now, how do you plug that in your calculator? Step 1, sorry, I was going to say get a box. Step 1, make sure your calculator is in degrees, right? And you know on the test I'm going to be going back and forth between radians and degrees. Just be really careful. If you get a negative answer for like the height of some dude, I'm not trying to say that they're in a different dimension. You just probably didn't change your degrees to radians or vice versa, yes? How do you plug that in? Exactly the way I've got it written. 1,000 divided by parentheses, 1 over this, and I think, does tangent on the calculator open a dumb parenthesis?
Yeah.
Well, make sure you close the dumb parenthesis. I hate that crap. It's like that little paper clip that would show up when you're trying to do a Word document. It looks like you're just shaking. You guys remember Clippy, or is that before your time?
I remember.
Remember Clippy? Okay. If you don't know about Clippy, feel very privileged. That was a dark time. The paper clip that wouldn't die. Try to plug that in your calculator. Let's see what we get. It looks, yeah, that's right.
Are we still incorporating that H?
No, this is h equals that business, right? We have solved for h symbolically. Now I'm trying to get like a number answer. Yes? somebody asked me how tall is that mountain, and I said 1,000 divided by 1 over. I'm like, no. How tall is it, Nathan? Let me know when you get an answer. If you're playing along. Serenity, what'd you get? Yes! And of course, what is that? 5,000 or 7 point blah blah blah. What's the units? Feet, right? That's because that's the units I was using, so that's the units at the end. Good. So you should get 5807 point something. I can't remember.
How many decimal points do you want to spread that's on this test?
I'll tell you on the very top of the test, it says round to. I think I said 3 decimal places, or whatever I say. At the very top of the test, I'm going to tell you wherever you use decimals, round to this many places. Yes. And if I ever don't say, 3 is a good, safe bet. Okay. And I think I told you, this problem is a decently difficult problem. Not because any individual step was hard, but because there are quite a few steps. So there's a difference between a problem being hard because the concept involved is hard, and a problem being hard because there's so many steps to get to the answer. You guys could all freaking set up these two things easy, but you have to first realize there are 2 right triangles that you could do that for, yes? So at this stage, especially on this test, if I start asking you to find this whatever, I give you this angle, find, you're looking for right triangles, because that's the only kind of triangles we can work with directly with trig. Might have overdone it just a little bit, but number 9 is a decently hard problem because of the number of steps. So the kind of problem you'll get on the test won't be quite as involved as this one, but it will involve some of the same thinking. Okay. How'd the first side go? I mean, if I give you this problem, are you guys happy? Yes, ma'am.
For number 1, if it's a radical like square root of 117, do you want that to like be changed into like?
Oh, I see. Yes. If you don't notice, you can reduce it. I'm not going to take like a ton of points off, but you should take a second and make sure. Real quick, was that a number that came up somewhere? Square root of 117?
Yeah, that's right.
Oh, good. Now listen. Did I tell you guys how to tell if something's divisible by 3? Did I already told you this?
It's when you, like.
117, what's the sum of those digits?
9.
If the sum of the digits of a number is a multiple of 3, 3 goes into it. Even better, since 3 goes into 9, if the sum of the digits of a number adds to a multiple of 9, 9 goes into it. So what is 117 divided by 9? I would give you this on the part where you could use a calculator, yes? What is 117 divided by 9? Batteries right now. 13? I guess. That sounds right? Yes, it is. So that square root of 117 is the square root of 9 times the square root of 13. So that's 3 times the square root of 13. If you do the whole problem and you leave it as the square root of 117, you might lose a point. It is something you have to look for. But if you miss it, the real concept is, can you construct the ratios? Okay. So it's not going to be the end of the world if you don't realize you can simplify some weird ass number you get in or out. Focus on setting up the trig functions, but kind of look, can I see real quick, can I reduce this thing?
By trig functions, you mean you want to know what cosine is?
Sine, cosine,
Okay.
tangent, and then secant, yeah. Yes, ma'am.
Can we take a look at number 4, finding the value of beta?
Yeah. Oh, yeah. You see. Number 4. Oh, yeah. Oh, this. Sorry. Dadgummit. I didn't even realize this is this is from section 8.3. Sorry. Real quick, just in case you're curious. Do you guys have your calculator? Does somebody have their calculator? Can I borrow somebody's calculator? Ooh. Here, just you're closer. Thank you, though, Christy. Right above your sign, do you see inverse sign? Okay. How does an inverse function work? What does an inverse function do?
You get the opposite of whatever.
It takes all the and then it, can somebody fill that in? Takes all the inputs in and switches them. What's the input for a sign, for example?
Cosec?
What's the input for a sign? What kind of thing is it physically? What do I put into a sign?
Yeah.
Angles, yes? So what's the output to an inverse sign? Angle. No, angle. Yes? If the input to a sign is an angle, and inverse functions switch the input and the output, what's the output for an inverse sign? An angle. So I'm not gonna, I just want to say this one thing. We didn't get to inverse yet, but just to, if I see this, the input to a sign is an angle, the output is a ratio. You guys agree? So the input to an inverse sign is a ratio, the output is the angle that would make that true. So what angle makes sine rad 2 over 2?
45.
I don't know. Remember, you got a special place in my heart. 45 degrees is technically right. Pi over 4 is a little bit better, but you're fine. You guys see that? So. Just to really make sure you understand this, I'm not gonna, I forgot this was on there. That's completely my fault. I didn't see it. This is from 8.3. But if I know that the sine of theta, did anybody do this problem? Oh, I can't see shit. Oh, there we go. What do you got, Jeff? The sine of theta is going to be 7 over 25, I believe. Did anybody do this? Negative? Yes. So if I want to know what the angle is, I just take the inverse sine of both things, of both sides. And then I can plot that in my calculator. That's what we're going to do in section 8.3. So I'm really sorry. Number 4, the last part of it is from 8.3. That's going to go in the next test. If you pull a lot of hair out over that last part of part 4, number 1, calm down. Just reach out to me, you're fine. And number 2, you're fine. That's going to be on the next test.
Can we actually go through part 4 a little bit, like how to set that up, or?
Number 4?
Yeah.
Oh, sure. Did somebody do number 4? Sounds like at least one person did, because they're like, I tried to do all of it, dude. And you. All right, okay. So, secant theta is 25 over 24. What does this tell me? Yeah, what quadrant are we in? We're in the 4th quadrant. So, personally, what I do, I think I did this differently on the practice test, because I think it's what most of you guys would do. I should have just done it by way. I draw a triangle. I get all the ratios. I use old Greek dude to fill in nothing I don't know. And then at the end, I go, what quadrant am I in? Let me make the right stuff negative. So I'll do that this way on this one. Can you guys help me draw the triangle? You know, like, well, Jeff, you make like a base and then a height. Thanks, guys. But where does 25 go in my triangle I just drew?
On top?
Good, because secant is 1 over cosine. So right now I know what cosine theta is, right? What's cosine theta?
24.
Good. So this will be 24. I'll just cut to the chase. And then I'll really cut to the chase. Well, who did this problem? What did you get for this side? 7. I kind of gave it away over here, but yeah. So just like a 3, 4, 5 triangle, a 5, 12, 13, there's also a 7, 24, 25 triangle.
I'm just assuming that you didn't want to cut to the chase, but use Pythagorean theorem to. So
Yeah, Pythagorean theorem. Yeah. Right? If I knew 2 sides of a right triangle, I know the 3rd. Now, listen.
On the practice test, you
Yes.
put -7.
What?
On the practice test?
Did you steal one?
Yeah.
I told you. On the practice test, I did this a different way. So I'm going to show you this way, and on the practice test, I did it a different way. Yes?
Where does 7 come
Where'd the what now?
from? 7?
Before it was there, what tells me the relationship between the 3 sides?
Pythagorean theorem?
Old Greek dude. Yes? If I call this y, what's old Greek dude say? What's Pythagoras say? 24 squared plus
Y squared.
y squared equals
25 squared.
25 squared. Now solve for y. And you will get 7. Yeah. Is everybody cool with that? Sometimes people forget to square root and that makes everything kind of weird, but yeah. Now listen. What is sine theta then? Just from this triangle.
24.
Sine theta. 7 over 25. And then I would keep going, but at the end I would go, oh, I'm in the fourth quadrant. What's negative in the fourth quadrant? What's negative in the fourth quadrant?
Sine.
Yes, the y. So sine is. So I would just put a negative there. You guys see it? Now, let me go ahead and give you the practice test, and I'll point out. Oh, you already took one because you're sitting in a good seat. I'm going to point out the way I did it here, because I think some of you guys might like this way better. I always apologize that the answer keys are in my writing. It's like you're already getting enough of that, but too bad. This is the other way to do this. I specifically put my triangle in the fourth quadrant, and then I know ahead of time that this side is negative because it's going down, yes? And then when I build my ratios, the sign is already where it's supposed to be. So if you like that way better, go for it. Personally, I just get my ratios and then I go, oh yeah, this one's negative, that one's negative, blah, blah, blah. Either way works beautifully, because you either put the negative one at the end, or you put the negative one at the beginning. It's still going to come out negative in the right places later. Is that okay? Does one of those two methods make sense? Okay, you can pick the one that makes the most sense and do it that way. Okay. I even forgot to do the last part of that when I made the answer key. So, you know, I'm averaging about a 97 on my answer key, so. Yes?
And we didn't use the 3 powers here, whatever.
We totally did.
Or
We totally did. The way I did it just a second ago, why did I make this negative? Because we're in the fourth quadrant. The way I did it on the answer key, why did I make this negative? Because I've drawn it, I've told myself, oh yeah, I'm in the fourth quadrant where the y piece is negative. Yeah. How you guys doing generally? You guys alright? Are you guys taking too many other classes? What's going on? Yes? Does anyone else have another test tomorrow? Wednesday? Do you have another test tomorrow? Wednesday, okay. You're all like, dude, at this point I don't sleep, so they're all the same day. What do you want from me? I understand. Huh? Quiz, okay. Tomorrow, same day as our test, yes. And the teachers, we actually get together and we desperately try to set it up so there's the most tests on a given day, because we are all evil. And apparently, I had to change my day, so I got out of the scene. So hopefully you understand that's all a joke. I, as a teacher, it is difficult for me sometimes to separate students having all kinds of stuff outside of my class versus how much is in my class that's making a student kind of like feel bad. You guys with me? So I've had to train myself to just realize what I'm doing. Do I do everything well enough? And if you guys have an issue with this class, you've got to come see me. If your issue is with me, please go see my chairs and correct the shit out of me, right? If I ever say something wrong or mistreat anybody, dear God, any of your teachers, you can always go see the chairs. If the chairs are the problem, go see the dean. If the dean is the problem, go see the vice president. If the vice president is the problem, go see the president. If the president's the problem, go see the chancellor. If the chancellor's the problem, contact the news. Yes? Are you guys moving? So don't ever feel like You're just one FM up on any level. You with me? And just remind you, if my office hours don't work, you could always, I've got some Zoom office hours I've already done earlier this semester. It's not the most exciting thing for me, but it's better than nothing, right, to help over Zoom if you need. Our test is tomorrow, so right now, if you're like, oh, I'm in section 7.2 homework, okay, stop trying to do every problem. Maybe you'll finish it later, maybe you won't. What's most important right now is to get practice for tomorrow. Do a few out of 7.3, and when I say that, I don't mean do the first 3 problems. Do a few from different parts of the homework. Then go to 7.4, do a few. Go to 8.1, do a few. It's not enough practice, but it's a shit ton better than no practice. Yes? And then you give that to me. And I'm going to go, what the hell? And you're going to go, deal with it, man. I mean, because this is your education. This is not my education. This is your education. I'm sorry, I'll stop. Anything else you want to focus on from the practice tests, quizzes, homework? Yes?
For 5C, cosine of pi over 6 is
1/2. What did I put?
3.
Did I put 1/2? No, it's rad 3/2.
Right, that's,
I love myself so much.
okay.
So on the practice test, this should be, here, let's correct this. Right here, take that away. What should cosine of pi over 6 be? Rad 3/2. And then you make that, we've done that so many times by now. You get that. That's what that answer should be. Okay. What was I thinking about? You never know what I was thinking about. Yes.
You said for 2 APD, that's like to practice with other calculator.
Sorry, which one?
For 2 APD,
Yes?
can you like do that
Oh,
with anyone?
are you guys all cool with 2A? This, I'm not gonna do this to you on the test, because that's really evil. I didn't put degrees on there, but if I gave this to you on the test, you're allowed to come up and kick me. But I'm just making the point, I didn't put degrees, so that is radians. Yes? But do you mean just to see how it looks in the calculator?
Well, because we can't do it with the calculator, can we?
Oh, I don't know. If I put this on the not calculator section, I'm gonna make them much easier to work with. I'll go ahead and tell you this. I did put it on the calculator section because I asked you to give me the answer all the way to decimals rounded to 3 places. Yeah. But I mean, this here you reduce, right? So you just divide by 5, and then you keep divide by something else. You can do it in steps if you had to do it by hand. Okay. Do you guys know in your calculator? Do you guys know about the fraction button? Does anyone not know about the fraction button? Here, can I borrow this? I'll show you. So what is it? 315 over 180. Yes. If I do that, I get this. All right, that's nice. But just to show you, if you hit math to fraction, look at that shit. Look at that shit. Gaze upon that shit. So if I do like 88 divided by 1056, I get this. Yes? Math to fraction. Kabam! Yes? Okay. So, I'm sure you guys wish you knew about the fraction button like 5 classes ago, but you got it. It's one big reason when I used to be able to teach math 88, they were not allowed to use a graphing calculator at all because it will do all of it for them. Okay. Anything else we want to focus on? Okay. by the way, just to make sure you guys understand, this will be on the next test. But what's going to happen is, real quick. Do you all agree that secant is 1 over cosine? So listen. 1 divided by something. Where will it have issues? Like 1 over x minus 1. Is there a value we can't use? 1 divided by x minus 1.
1.
I can't use 1. What's going to show up on the graph? What do I put when there's a value I can't use in my domain? What do I put?
The vertical line.
You cannot go here. Put a wall, yes? Put an asymptote. What's going to happen here? Can 1 divided by cosine theta, can that be undefined?
Yes.
When?
When it's 0.
When cosine theta is 0. Can somebody give me a value where cosine theta is 0?
0.
No, cosine 0 is what?
Oh, cosine.
When is cosine 0?
90
1/8.
degrees.
90 degrees, so pi over 2. And you agree negative pi over 2, right? Here, it's going to have an issue. There, it's going to have an issue, yes? Because cosine likes x, if I'm on the y-axis, is going to freak out. You with me? So if I try to put pi over 2 in, is this going to be cool with that? So what do I have to put here then? What do I put here to tell it you can't go here?
Vertical
I'll
asymptote.
put a freaking vertical asymptote. For the same reason. Why did you put a vertical asymptote at 1 when it was 1 divided by x minus 1? Can't go there. You gotta, so I gotta put asymptotes here, here. You guys kind of with me? Now listen, I'm not gonna suddenly teach that because you got enough to worry about. But just to show you,
So like for example.
on the practice test, I try to give you a little idea of what it will end up looking like. Do you see that asymptote? Because that's where this is 0. Do you guys see that?
So for cosine.
So there's an asymptote here? Okay.
So
This is going to look like cups, basically. We'll get there. Don't worry about it. I just put it on in case you're curious. Yes.
So for cosine, could you put a vertical asymptote in pi and 2 pi?
0 and pi. Because we like to keep our main thing we draw around 0.
Yeah.
So 0 to and 0, there's going to be an asymptote, and pi, there's going to be an asymptote for secant. I'm sorry, for cosecant. And number 7, I just showed you what the tangent will eventually look like. We're not there yet. Okay. Has anyone recently tried the Sissel for the first time? Anybody? Has anybody been going to the Sissel? Does anyone remember what the Sissel is? Yes, Khadijah, I know I've seen you there. You've been in there? I think I've seen you in there. Have I?
You tested me last time. I was with you the whole time.
I'm sorry. I suck. But if you haven't gone in, it's not too late to join the class. There's a class you have to join. It's a 0 credit class. You can get in there. You can get. In fact, here, real quick. Do you guys notice that the schedule was put up for the fall? It's in web. It's in self-service. So the schedule for the summer and the fall is up. Summer, I'm teaching a 180, and in the fall, I'm teaching a 180 and a 280. So if you really wanted to, if you're like, I can tolerate this dude for a little while longer. You can take my Calc 1 in the summer and my Calc 2 in the fall and just be done. If you have to go through that far, you can just be done with your Calc 2 by this December. That's crazy. If you want to avoid me, you can look at the schedule, see who else is teaching the stuff, and then go see if they're doing the Sissel. If you go into the Sissel, right when you come in, right, see, you go into the Mass Study Center, and then you go like this. Go into the Sissel, and right there on the wall is a list of all the teachers and when they're in there. So if you collect all the teachers who are teaching 180, and then you go there and you're like, what is this person in here? You can actually go and freaking talk to them. You can have them help you, so you can kind of see what they're like. You guys with me? That's what I told my colleagues. I'm like, holy shit, if I was a student, that's one way I would use the damn thing. Let me meet some of my future potential teachers and see what they're all about. Okay. You already know me, obviously, and some of the guys like, yeah, man, I've had enough. Well, then there's other people, so that's okay. Alright, anything else? So many things. So I can't stress to you enough how, in fact, let me just say this, we're close enough to the end of the semester right now, I think. I don't, how do I say this? Should I say this? Homework ends up being worth 5% of your grade. You with me? How do I put it on the syllabus? I say quizzes and homework together are 20 or 25%, yes? Why do I do that? Because I'm trying to trick you to do the right thing. I try to make it seem as if homework's worth more. In a perfect world, I would make homework worth nothing. I tried that once and everybody died on the first test. I'm like, oh, shit. Also, I don't let homework fail somebody. So like at the end, after we do the final, if I put all the grades, that's quiz grades, test grades, and you pass, and then I put the homework grade in and you fail, you passed. I do not let homework fail a student because in my mind, it's already hurting you if you're not doing it. You guys see? So if I'm like, you passed even though you didn't do much homework, okay. You guys understand? Do you guys really understand? Did I just say, oh, homework's not important? Did I say that at all? But if I say that too early in the semester, people hear that like, 5%? Oh, and he doesn't let up, oh, screw homework, and then they die. I'm like, homework could save you from failing. Homework could save people from failing. They would get like a 68 average, but well, that's like a 69 average, and then the homework gets them up to 70. I let it save you. I don't let it pull you under. Yes. All right. I'm sorry. Yeah.
Are we gonna do that?
Yeah, you're gonna get it after this test, and then I'm gonna give it to you after each test, and then I'll give it to you again right before the final. Yeah. Yes. Sorry?